Hello, this is the TechHub project, and here is the tutorial video for the 10th product from the project. Let's see what project we had on 10.1. It's a personalized stamp. So I will download both the ETL files from the TechHub website, and I will go to the first software, Ultimaker Cura, where we had the 3D Creator printer and the generic material. And with this, I will bring both of the file, yes, and I bring both of the file. Oh, they are big files. Okay, I don't scale them. I'll just discuss how we'll set up them. Yes, so the first the first stuff that coming is just we need to rotate them and put with this holder up. But when we manufacture some product, we should think that the product is how to say it, have some functional role, yes, some functionality. So in this case, we need to think what is the function of this product, and in this case it's a stamping. So this is the most important surface on this product. We can put it bottom because the quality will be, let's say, not very good. So in this case it's an exception. I will keep the product here, and here we will just put structures because the holder is not very important. It's important, but the most important surface is this from top. So I will keep the product in these positions and just go, because we need a very good precision on this surface, because it will left printed print area on some paper or some other surfaces where we need the precision. So I will use fine fine profile. The quality will be same. You see, it's same value. For the shell, it's not important for me for now, but I will keep 0.8 millimeters and 2 layers on each well. For infill, I will use 30%. It's enough because there is not need more, and it will be grid type. For the material will be 210 degrees and 60 degrees for build plate on initial layer on rest of layers. Yes, and from here, yes, I go to settings and I take build plate temperature for initial layer. I don't need it. I need just the general temperature, and you can see it's disappear from default layers, from default setting. Yes, so here is the setting for each category, and I can add some parameters, or I can remove from setting some parameters, and they remain in default value. For speed, it will be 50, 50, 25, 25. Yes, I'm agree with this value. So it will be 50 millimeters per second for the general speed and for infill speed, and 25 millimeters per second for well speed and for initial layer speed. The travel, yes, I want to be enabled to retraction. So the nozzle should retract when some surfaces are printed. Cooling, I want to have enable cooling at 100% of working. The support, yes, we need. So I click on it. So I need support everywhere that the software thing is necessary. When you met the surface on hang on at 45 degrees, I need a support of line type in order to be easily to remove, but the height here is very big, so the line is not enough. So I'll take the grid one and 50% of infill. And the build plate adhesion, yes, because the parts are very big and the contact area is small, I will use here a brim. So the brim is used when the surface of contact with the build plate is very small than the rest of part. So here will be the brim options. And if I take the brim, I have the brim option, brim width, yes. So I can take the brim width, it's 8 millimeters, yes. And I can put and I can put this brim. So if it's 8, let's see if I put here 15. And let's make a simulation to see. It will take a long time because the precision is big, the speed is small, and yes, it's almost 16 hours. And let's see how this product will take a look. It's look like this. Don't worry, it's not full. This is just a support material, and you can see how it's look on product. So we just broke this structure and take it off from the product. And this structure is created just to support the up surface. Yes, so it's just created like a bridge in order to support this structure from the product. Yes, and here you can see the interface of the support with. So this is the first layer. Let's see how it's created. So this is the first layer of real surface, and you can see that the printer starting create the bottom surface of up part. Yes, and this is the wall layers. Yes, both of wall layers, and after that it will start to create the brim. Yes. Okay, and now you can see it close the bottom layer, and this is the way how software simulate the bottom layers of this part on support. If there are not, we don't have support, this layer can be generated because this material can stay on a hang-on position, suspended, let's say. So this is why we need support. Okay, so this is the process on this software. We just save it. Yes. So this is the name. I will don't keep 10 in front, just personal stamp, and this is awesome, and save it. Good. Go to Z Suite and take a start a new project, M300 Plus, of course, and also bring both USTL files. Look where they are. Okay, so I will change the positions. Of course, I will keep them in the same positions. Yes, and I will go a little bit up with this one. Yes, in order to have the space for this one, 155 in order to be on middle of this, and just from here move it close to the first one. I will left just 2 millimeters between this. Okay, I think it's enough. Let me rotate to see. Yes. So I have the space there. Yes, good. And here, of course, will be same settings. So from here, I will go to advanced. I will keep Zortex material. The type of material will be Z-Hips. And I said, put the smart bridge and the little part of support when you met the angle hang on 45 degrees. The gap of support from the part will be 0.36 millimeters. So this means this is the distance between the surface of the product and the support structure. And the density will be 3 millimeters of this density. These settings will be remain like this by default. And here are the usual settings: the nozzle 0.4 millimeters, the layer thickness 0.19, the quality normal, or we can use high here. Yes, I will use a high. Type normal, pattern will be 1, the infill will be 30, the layers 5 and 5, a random seam of each layer. Yes, the first layer gap will be 0.3 because here is a small surface, and the platform and raft gap will be 0.25. Just preview it. And let's see what we obtain on this product. Okay, and here is the white is a support. Yes, this is a support structure, this is the raft, and this is the product. And let's go through the product and see how the support look like. Yes, I will rotate and you see it's a line type. Yes, and had just one perpendicular direction in order to increase the resistance of this support. And it's easily to remove on post-processing because it's just a line, and we broke this and remove it from the real part, and we obtain a very fine up surface that will left a very good print on what you want. So just export it again, and from here just delete 10 from top and this, and we had it saved. That is how we set up the setting for part that we think it should be rotated in another position, but depend of active surfaces, of master surfaces, we keep them in let's say not natural positions. Thank you for watching, and wait you for the next one.